So we will begin with core team updates if everyone is
Arya,
here.
you're almost inaudibly quiet.
Sorry. So we will begin with core team updates, starting with the Zcash Foundation on Zebra, and then the Electrical Link Company on Zcash D, Zale and other core libraries, and then finally Zeno. And then we will go to R&D updates from Kedit, Shielded Labs, and again from the Zcash Foundation for Frost. And then we'll have an open announcements, some time for open announcements, and then some time for general discussion. So starting with core team updates, Zebra, I believe, first, what are Arborist calls? These are biweekly calls where Zcash protocol contributors convene to discuss upgrade timelines and processes, protocol R&D efforts, design and implementation of new protocol features, and to identify blockers and any unresolved issues. The purpose is to make Zcash development more accessible for a wide set of participants and to provide more transparency for the community at large. Who can participate? Anyone interested in learning about the Zcash G protocol. Zcash protocol and development can register at zcasharborist.org. And if you want to suggest a topic for discussion or present an in-depth agenda item, email arboristcalled@zfnd.org to request a slot. Other ways to get involved, we have Zcash community grants at zcashcommunitygrants.org. There's a Zcash R&D Discord, a community forum, and you can find all these links by going to zcasharborist.org. So core stack updates, I believe Merrick is in the hot seat. Merrick, take it away.
Yep, thanks. In the last few weeks, we rebuilt a bunch of things in our CI and Docker, and we also changed the way we configure Zebra in Docker. Some of these changes are breaking changes, and the one that most people will probably notice is that the RPC endpoint is not enabled by default anymore, and users will need to enable it manually. Then, as regards RPCs, we extended the get block, get row transaction, and get peer info RPCs. We added the invalidate block and reconsider block RPCs. We added support for negative heights to RPCs that supported in Zcash D. And we fixed the bug in trusted chain sync that was bugging the Zeno folks. We also brought back the internal miner that is useful for generating blocks on testnet and reg tests. We fixed the order of outputs in Coinbase transactions as well. We had it the other way around than Zcash D, and this was confusing block explorers since they rely on the order. And the last thing I have here is that we refactored the way Zebra handles its internal database format upgrades. This was to allow much better maintenance for new upgrades as they come. And I'd like to thank all external contributors and all people who opened issues. Very much appreciated. That's all from me.
Another quick shout out to Strad and TUR for pushing the Equihash PR through and helping us get the internal miner in. So next in the hot seat, I believe, is Chris. I'm guessing, but.
Yep. So in the past week, we have new releases of, or I guess since the last Arborist call, we have new releases of the whole Libra Zcash crate stack. This brings in well, a number of things. The big thing is a transparent gap limit based wallet recovery. So you know, Bitcoin style wallet recovery for HD wallets. The other major area of focus is, of course, Zale. We now have a branch where we're able to sync the chain using Zingo as the source of data, and now are working on ZSend Many. The other piece that's going on with Zale is we talked a bunch to the ZWIF developers over the last couple of weeks, and I am in the midst of implementing Zcash D wallet DAT import into Zale via the ZWIF export. So that's all. That's all the high level stuff. Couple of other things that are going to be relevant. One is that I think Dara, Emma, and Strad haven't joined yet, but Dara, Emma, do you want to talk a little bit about your
I have
post-quantum
joined.
work? Okay.
Yes. Let's see. Shall I screen share?
Well, I mean, this is just the update, so we can talk about it in more depth later, but it's worth giving a high level overview, I think, right now.
Yeah. So basically, the idea is to change the construction of notes in order to kind of enable a smoother transition to post-quantum. So the problem is that the current note commitment scheme is not post-quantum binding. And that would allow a quantum adversary to violate balance, to forge notes, basically. But there is a change that we could make, which is a relatively simple change. It doesn't actually change the consensus protocol proper. It only changes how notes were constructed in a way that sort of does not affect consensus. So it does affect the note encryption and decryption. So if we do that, then the effect would be that new Orchard notes created by a wallet that supports this could later be spent using a post-quantum protocol. And so we wouldn't be in the position of having to sort of completely disable the previous protocols and not have a way to spend existing notes safely. So I think this is a very good idea to do this. I'm currently sort of finishing the analysis of the changes, but the analysis seems relatively straightforward. So I think this could potentially be done at the same time as the memo bundles and NU7 changes to note encryption.
Any questions for the ECC? So next is Zingo Labs. I don't see anyone from Zingo. I don't see anyone from Cadet either. I can give an update for them. They're just mostly focused on the changes to the zips in response to the zip editor's comments. And I don't know who's here from Shield Labs, but
Hey, I am.
awesome.
Yeah, so no update on the NSM. Basically, we're still waiting on a couple PRs to be merged to Zebra. These include 9300 and 9256. I reached out about this in the Zcash R&D Discord, and it sounds like ZF or Peely said that ZF hopes to get it done this week.
Okay. Any questions for Shielded Labs?
Do you anticipate that getting done this week? 9300 update Zebra dependencies to use the latest Libra Zcash, which will allow us to rebase the Libra Zcash PR to the latest main branch. And then Arya, you had previously said that you wanted to hold off on ZIP 233 implementation until 9256 is merged.
So that was merged this morning.
Oh,
I
awesome.
think. Yeah. So if you rebase that, we can start taking a look today.
Okay.
Or this week for sure. Yes. Going back to Zingo, Arlo.
Hey, yeah, I thought just give a quick update. So we've now got in fetching compact blocks by hash, which I think was required for Zale. So that should be functional now. Also just finished off the versioning for entry link and entry kind in Zcash history. So that PR is now ready for review. And when that's in, we will be quite close to having the remote restate service PR ready as well. So that's kind of the main updates there. I think we also have, I put a bit more detail on the forum regarding the continuation grant and kind of what that's specifically for and why we think that work's required. So yeah, it'd be cool to have any feedback on that.
And then Shielded Labs and DCC for Crosslink.
Yes, hello. So at Shielded Labs, we are in the midst of our milestone 2. So that involves using Malachite, which is a Tendermint BFT implementation in Rust, and setting that up so that there's a Malachite network that's consenting about what proof of work blocks they see. And then part of the milestone is also writing early draft documentation for like the format of the BFT blocks and how they are validated. And then we've also been working on some diagnostics, and we have a visualization project, and we have a video that I'd like to share if possible. Let me see. Share screen. Oh, okay. Only one person can share at a time. All right, here we go. So this is on the Shielded Labs YouTube channel, and here's a like 5-minute video of this visualization.
I don't hear the audio.
We don't get any audio from it, so.
Oh, interesting. Yeah, I don't know exactly how to do that.
I think it is possible.
Maybe that Zoom isn't sending the audio part.
All right.
Right, you have to select the right device on Zoom, which will be the probably the monitor of your output device.
You could also, I think, if you do a new share and you go to advanced and share a video, that might work.
Oh, let me try that then. That seems more. Oh, I don't see that option. Oh, here we go. Okay, I think I found an option that could work. Try again.
I'm Andrew from Shielded Labs. I just wanted to share some of the progress we've been
This
making
working?
towards milestone 2 of Crosslink.
Yep.
As you might have seen from our public roadmap, milestone 2 involves releasing an executable that anyone can run that has a BFT chain that mirrors or shadows mainnet. Currently in the background, I have a Zebra node even, running mainnet. And if you've run it before, there's a little bit of extra data that's not normally there. And this is the output of milestone 1. It is just showing as blocks become final, which is currently based on when they move past the reorg limit, then they just get printed to the terminal. And the only real interesting thing happening here is that the hashes are being highlighted for the last couple of characters, depending on basically the fewest number of characters that you can use to uniquely identify a hash within a batch of a few. That's not particularly important though. So, as you may know, Crosslink involves 2 chains, the proof of work and the proof of stake chain. And currently this is only looking at mainnet, which is the proof of work chain. As part of in order to present proof of work and proof of stake chain next to each other, it's not obvious how you do that in an ASCII mode, and so we've taken the decision to create a GUI visualizer, and that's what I'm going to demo here. So let's see if I can get this working. There we go. I've got it running in the background here. And the general idea here was basically just to make a presentation, an interactive presentation that was similar to what you draw on a whiteboard. So we've got circles and lines. The circles are the blocks that are being generated. The lines are the connections back to their parent. You can see the height of a node and the hash of a node next to each other. While we're generating arbitrary visualizations, we may as well add some more proof of work specific stuff. So the size of nodes, which you might see is different in certain cases, represents the number of transactions. So here we've got just one, the Coinbase, and here we've got 8, and you can see this one's a bit larger. The distance between nodes represents the amount of work done. So if you have 2 side chains next to each other, you could distinguish which one is the better chain by just visually which one is longer. And of course, as part of crosslink, finality is an important thing. In milestone 1, we added a just fiat RPC call to determine finality directly. And so if I run that here, we can see that this node here and all the ones after it have been emptied. They're now empty circles, just to show that they're not yet final, whereas everything below is finalized. Okay, so we can set that again. And let's just kind of scroll up and find that. You can see that we've got all these nodes going past. They just get paged in as necessary. And here we are. Here we have the new finality location. We can go backwards, although that's only for testing purposes. And there we go. Let's find that point again. So the last thing to show is, well, we've got one chain, that's great, but the entire purpose of this is to have parallel chains. And so you may have been wondering what this mysterious box in the corner here is doing. And that is just a debug input to put any text. And now we can generate new nodes in our parallel chain. Currently, this is basically just being arbitrarily placed, but it'll be more relevant shortly. And so the protocol is called crosslink, though. So right, so we need to have connections between the two things, and so we can, for the moment, just type those in. For this BFT placeholder, we now have a link going back to the proof of work chain. Currently, this can also point basically anywhere. Currently, there's no actual requirement that this has to be final. I think that's pretty much all for this update, but I should have some more to show you soon. See you, everyone.
All right.
Oh no.
Sorry.
Did you want to show something else?
No, that was it. So yeah, we're working on that diagnostic tool to sort of visualize the chain state and at the same time plugging in Malachite. So the goal for this milestone, just as a reminder, is to have Malachite connected to Zebra and sort of reading the proof of work state, but there's no modifications to the proof of work state. And then in the next milestone, milestone 3, we intend to modify the proof of work headers, but none of the transaction semantics. And that will be like the first like prototype of the full crosslink functionality. Of course, all of the BFT side is just using a proof of authority, so just a list of finalizing nodes that's useful for testing. And then the milestone after that, 4, is where we begin implementing the actual staking rules. So any questions?
So which milestone are the consensus rule changes? The ones that determine which block is final?
That will be the next milestone, so milestone 3.
Okay.
Yeah. And we're hoping for this milestone, milestone 2, to make a fun thing, which we call mainnet shadowing mode, which is connect to the ability to connect to mainnet and also participate in a BFT network that's read-only. So it's not interacting with mainnet in any way, but whoever is in this mainnet shadowing mode network can see with each other that they're validating the same or finalizing the same blocks. Of course, they're not really final.
Cool.
That was pretty impressive.
Yeah. So let's see. So the full protocol requires that each node kind of ratchets its finalization state, so it can't go back. I know that you're only sort of testing the, but let's see. Yeah, I guess that's in milestone 3.
Yeah, so just one thing that comes up on that tangent for me is that during this milestone, we want to determine the right layer to write tests that will allow us to write tests of sequences of both kinds of blocks and then verify that we're in the right state in portions of Zebra. And so for this milestone, we want to try to pick a layer and then write some tests involving rollbacks for the proof of work side, including, we want to be cautious about BFT-based finality versus the rollback limit that's already in Zebra, because those can interact and we need to be careful that they interact correctly. So eventually we want to be able to verify how they're interacting completely with tests of rollbacks.
Yeah. Oh yeah, so the BFT chain is also essentially a tree, because you can have parallel blocks that haven't been, that are not considered final on the BFT chain. So
do you mean proposals that haven't been finalized?
Well, if you consider Streamlit, for example, it's possible for there to be sort of parallel blocks that are not final yet on the BFT side. So the prototype just had a linear chain of BFT blocks. Is that right?
Yeah. So we might. I mean, my inclination is to have an abstraction where we ignore those and we only pay attention to known final blocks. But it might be nice to diagnose the BFT protocol better if some of those could be visualized. Yeah, and branching is still a to-do for the diagnostic visualization.
Try our new and validate block RPC for rollbacks. So next is the Zcash Foundation again for Frost. If no one is available for Frost, then next is open announcements.
Hi, sorry, I'm here.
Oh, hey.
I wasn't promoted. Oh, I'm still questioned from Zcon. Excuse that. Yeah, so there isn't much to say on Frost since last time. We had the audit from least authority for the Frost demo, and we're just still working our way through that. Yeah, and then once we've only got a little bit more to go, and then we'll send it back to them and see what they say. That's all the updates I have.
One note is that the protocol that Emma was talking about earlier for post-quantum resilience will have implications for the Frost key generation. So, but I think there's something there that's already sort of in need of specification, and before that specification stabilizes, it ought to take these changes into account.
It might actually be useful to dig into a little bit of the detail there with me. Let's see if I can screen share. Can you see that?
Yes.
Okay, so basically, this part is the key generation for let's see. Yeah. So normally for without Frost, you would generate NK, ASK, and RIVK from the secret key SK. So if you're doing a distributed key generation in Frost, then each party has a different ASK and you generate those differently. So the thing that you need to change in this case is that RAVK has to basically commit to NK and AK, and that's necessary for this commit IVK to be post-quantum binding. So it's pretty straightforward, but there is a change to be made to the key generation to make sure that that's the case, and it doesn't dictate any particular key generation algorithm, because the only thing that changes is the generation of RIVK. Yeah, I think that's it.
And in regards to changes to Frost, we are sort of moving away from active work on Frost now. But I mean, obviously, like, it's always good to have these conversations and figure out, you know,
I mean, this
want to do more, where we're going to welcome PRs from other people. But I think this is like, it's a good conversation to have about whether or not we want to do any more work on Frost at the moment. But I think, yeah, that's probably a conversation we can have.
I mean, yeah, this is straightforward, and it's specifying something that sort of needed to be specified, that's a to do in the current zip. So I mean, if necessary, I can make those changes. I think that's straightforward.
Okay, great.
Nate asked whether the diagram is public on HackMD. Not quite yet. It's not quite ready. I'm hoping to have it ready today or tomorrow. If you want to see the rest of the diagram, by the way, the main other change that's needed is when you're generating a note, when you compute the RCM value, that's computed in a slightly different way. So it's committing to GD, PKD, and V, and for ZSA it's the asset base. And that's the only change needed, basically, for the time being. So there's some security analysis on how the post-quantum recovery will be done, but that's the only thing that needs to be changed so far.
Okay. Now, open announcements if anyone has any. Okay, open discussion. Anything anyone would like to discuss?
There's one thing that I had for ZCG. I brought this up at the last Arborist call, but most people were in Sophia, so I'll bring it up again. Pitma or Renee recently submitted a grant proposal for the Zenith Zebra wallet to add support for Frost multisig and an integration with the Keystone hardware wallet. And we wanted to hear from the ecosystem developer teams on this call, whether they use Zenith, if they plan to use it, if they know others who do, and whether you feel these added features are useful and something ZCG should consider funding.
Thus far, I have not used Zenith, so I can't comment.
Yeah, we don't use it in Zebra directly either. I remember though that the team opened a bunch of issues and they were useful.
So maybe we should take a closer look if CCG needs some input.
Okay, that'd be great. I can send you the link after the call.
Thank you.
Thanks.
So I have a quick small item for Dara Emma. Re-randomization in MLChem. Do you still think that this is going to be an issue or any change?
I think, that's a longer term speculative thing that will only be needed if we wanted to do diversified addresses in the post-quantum protocol. But it's quite possible that we'll only use symmetric cryptography for the core algorithm that needs to be implemented in the circuit. And we'll use some of the sort of point-to-point transmission of notes through LixNet or whatever instead of the public key crypto. I think that means that we possibly don't need diversified addresses, because the whole point of diversified addresses is you can give out an address containing a public key to multiple parties, and they can't make it. If you have a more interactive protocol where you have a two-way communication channel to send the note, then you don't need that.
Thank you. So so that approach also has advantages for scalability because you're not doing note scanning. Just one more thing. You might not have to do note scanning in the future. That's good news.
Mm-hmm.
Any other items for open discussion from anyone? Nate?
Oh, yeah. I mean, I have heard from other Shielded Labs folks that Sean Bowe has published a blog post about a new scalability architecture, which also involves changes to like the payment interaction protocol. So I'm looking forward to reading that today. And it just came up hearing Dara talk about different ways to transmit notes point to point.
Yeah, they're entirely compatible. I think the motivation for making those changes is both scalability and post-quantum.
Any other items for open discussion? Going once, twice. Okay, I think that concludes the Arborist call. Thank you again to everyone who's joined here or is watching later on YouTube. Have a great morning, afternoon, or evening, wherever you are. And bye for now.
Thanks, Arya.
Bye.
Thank you.
Thank you.
Thanks.